Welcome to the Ocean Encounters virtual series from Woods Hole Oceanographic Institution, or WHOI, as we like to call it for short.
What you can't hear is Ralph's alarm has just gone off saying leak. So we're at 450 meters and we have got water in the bottom of the submersible, which is why I'm bending down and I'm now licking it to find out, is that salt water? Big problem, or fresh water, maybe we've knocked over a water bottle. It's salt water. Long story short, 20 minutes later, found the leak, leak's closed, we carry on diving.
I've had a very similar experience. I managed to convince the pilot if we just kept going deeper, the hatch would seat better.
Did that work?
No, we had to track down the leak and stop it, but we did, and we carried on.
This is a picture taken in 1986, I think, of Alvin and a young Andy Bowen engineer here working with what at the time was one of the earliest sort of versions of tethered vehicles. You can maybe make it out on the front of Alvin is Jason Jr., which we used in 1986 to explore the Titanic.
The ocean impinges on every part of the world and affects all of us. Even if we live 1,500 miles inland, we affect the ocean and the ocean affects us. And so we need to be cognizant of those linkages, and we need to work together, as all of humanity to solve it. And I love Orla's words of encouragement for anybody that might be watching to just get in there and do it.
Each one of these yellow dots represents an acoustic receiver that we put around Cape Cod. Anytime one of our tagged sharks swims within the range of one of those receivers, generally a couple of 100 yards, the receiver detects who that shark is. And that basically tells us when and where the sharks are spending their time. When do they show up? Where do they spend their time? And when do they leave? They give us a really nice look at the fine-scale local movements of these animals. And once we have a very predictable pattern, we'll be able to forecast those areas that people should avoid because this predator-prey relationship is happening. Let's remember, this is a natural ecosystem functioning properly. Numbers of seals being consumed by sharks, the top predator taking out the mesopredator. And what we want is we want to preserve this while at the same time cohabitating with this species.
So really, for the first time, we're going to fly you through the ocean with a mako shark. And so the top graph is showing you the position in XY coordinates, and then the bottom graph is that same sort of graph showing you the depths that these mako sharks are going. So it starts out on the shelf and not making very deep dives, but as soon as it leaves the shelf and gets into deep water, it's making dives down to 800 meters. It's heading a warm core eddy, back up into the surface again into relatively warm water, skipping around the edge of that warm core eddy, but again, diving to over 1,000 meters in that time. So really, this is allowing us to visualize in a new way how these sharks are actually interacting with their environments. The next 10 years really is going to determine what the future of our oceans will look like. Are we still going to be able to go and see apex predators in the ocean like we can now? My 12-year-old daughter, Phoebe, has never seen a whale shark, and I want to make sure that she can still go and see whale sharks. But we all need to make decisions now for that to happen, and it's a really critical time.
I lived a double life at Woods Hole. I was a scientist there, but I was also a naval intelligence officer. And I was asked by our government to investigate 2 submarines that we lost during the Cold War, the Thresher and the Scorpion. And when I found the Titanic, I must say they were rather upset. They said, Commander Ballard, your job was to look for the Titanic, not find it. I've done 157 expeditions all over the world, down to 20,000 feet, but by far the most dangerous things to dive on are shipwrecks.
There's an estimated 200 shipwrecks within the sanctuary, but so far only 12 of those have been documented and identified by name. It was lost in 1898 with all passengers and crew on board. There were no survivors. This tragedy happened in the middle of a massive storm called the Portland Gale, which took place 3 days after Thanksgiving. And as I said, there were no survivors, so it became very much an iconic wreck nicknamed the Titanic of New England.
This is a vision that I've had for, 10, 15, maybe even 20 years more, which is an ocean that is less remote and more accessible. An ocean that I like to think of as always on, always connected.
With ROVs and AUVs and with a platform such as this, we'll be able to stay down much longer and learn much more about this life support system. And at the end of the day, we go back to what my grandfather taught me when I was growing up, which is people protect what they love what they understand, and they understand what they're taught. Together, we can look forward to a much better future if we take care of our life support system. And I'm really excited, I really am, because today's world is starting to get tuned in to the fact that this is a little oasis in space, and the water part of our planet is what makes life possible, and what makes life feasible for the future, and what makes life so unbelievably enjoyable and blessed for us all.
And this is called Myriad Under Ice, or Nuice for short. And this is a vehicle we deliberately designed specifically so it can get all the way down to the bottom of Earth's deepest oceans in the Arctic, even when there's 90 to 100% ice cover overhead. So it's a completely new direction that we've been able to go to. It's a new boundary we haven't been able to explore previously. And it's pretty cute that we've only just about learned how to do that. September of last year was the first time we were able to manage a dive to the bottom of that ocean floor. And so we've just about looked how to do that on Earth, just in time for NASA to realize that they need to go and do this all over again in multiple different other locations in outer space.
These two worms are chock full of bacteria. They're stuffed full of them. And those bacteria are eating sulfur, the volcanic energy coming out of in that shimmery flow you see everywhere. And then they're providing carbon to their host. So you can sort of think about this like if you eat lettuce for dinner, maybe a hamburger, right? That's a plant that's produced it, and then the cow ate the plant. In this example, the microbes are using volcanic energy instead of sunlight to make carbon, which provides the food source or the hamburger for those two worms. This process is known as chemosynthesis, and these microbes form the base of these amazing food chains.
One of the challenges we have is that we have to think about what we call agnostic biosignatures that don't assume life as we know it on Mars or life as we know it here on Earth when we're trying to look for life in these ocean worlds. We have to really try to think a little outside of the box and keep our minds open that life may not work exactly the way it works here on Earth, especially in ocean worlds like Titan that has like methane lakes. Life might work completely differently.
There was a spawning event. It happens once a year, literally about 9:15, a few days after the last full moon of summer. And it was such a glorious, uplifting experience to see, what can I say? It was like heaven on earth. All heaven broke loose.
The name of the disease is stony coral tissue loss disease, and as the name suggests, it does cause corals to lose their tissue. Here's a picture of a coral that's affected by this disease. The disease lesion where the coral tissue is newly lost is that white band. And so that white band of disease travels across the colony. So the colorful brown tissue of the coral, that's still alive, that's still healthy tissue. And then what's kind of a greenish yellowish color there has already been impacted by the disease. That's dead coral skeleton you'll see. So this is affecting many corals in the Caribbean, up to about almost 24 species, which is one of the reasons that it's really problematic. So here's some photographs just showing some of these corals that are affected by this disease.
A coral reef has a lot of different colors on it, lots of different browns and greens and reds and all different kinds of colors. But on this reef, there was a lot of white. And we had just been at this reef the month before and had not seen anything. And in this video, you can see there's just these bright white patches on these corals. And that's, as Amy described, those are parts of the corals that have basically liquefied, and the living coral tissue has come off of the coral. So what was shocking to me was the sheer number of corals that were affected.
If we keep doing what we're doing, there won't be significant numbers of coral reef in another 50 years, because this is the trajectory. They're really declining. Cause for hope, though, this conversation, awareness, films such as Blue Planet 2, getting people to be tuned in and turned on about the little creatures that live there, getting to know their faces, their personalities. They're not just pieces of meat. These are living systems worthy of our affection and of our care, and to realize that they're important to us because we need a healthy ocean to have healthy people.